Hello, how are you today? Let's work with risk-neutral valuation in 3 steps. First, which inputs do we need for the estimation of a call option or a put option value? Second, which formulas do we need? And third, a couple of numerical examples. This is chapter 8. Okay, first, inputs for option value. There are 5 inputs that we need to determine whether this is a real option or a financial option. And the strike price, which is fixed, is written in the contract, or it could be an amount to be paid or received in the case of a real option. For example, if the option is related to a house, which is the underlying asset, then the strike price in a call option would be the price to pay for the house. In a put option, it could be an amount of money to be collected in the future, but it's fixed. It doesn't have volatility. It's determined. We know it in advance. Then the other price is the underlying asset price. An option is a derivative because its value comes from the value of another asset. This is the asset. So the underlying asset could be a commodity, it could be a currency. In the case of a real option, it could be a project. It's the asset that is behind this contract. And it has volatility. That price has volatility. The volatility is attached to one of those prices. So there are 2 prices, the strike and or exercise price and the underlying asset price. There are 2 prices. One of them has volatility. Volatility could be expressed in different ways depending on the valuation method. In Black-Scholes, volatility will be expressed as a standard deviation per year, a percentage. Here in risk-neutral valuation, we are working with binomial trees. So volatility will be 2 numbers, an upside movement and a downside movement. That's the way it's going to be expressed, meaning that, in other words, the value or price or of the underlying asset could go up or down by some number. T, time to expiration, is the time during which we have the right given by the option, by the contract. It could be a right to buy in the case of a call or a right to sell in the case of a put option. Finally, the risk-free rate of return. This is very easy to find, for example, the return on a T-bill. Now let's work with a very simple tree. We have here a 2 steps tree. This option expires in 1 year, but the tree, as you can see, has 2 steps. So we need to determine delta T, which is capital T, the time of the option until expiration, divided by the number of steps. This is important because we are going to solve the trees from the right to the left, from the branches to the trunk of the tree, and we need to discount to present value in each step. In this case, if the option expires in 1 year, delta T is 6 months. For example, let's consider this option. This is a call option where the underlying assets price today is $50, but it could go up by 1.5. We simply multiply. This is the upside movement, 1.5. So 50 times 1.5 is 75. We simply multiply. Or it could go down. It has volatility. It could go down by D equals 0.5. So 50 times 0.5, half, 25. We call S to the present underlying asset price today, and SU and SD to the value, the possible price in the next period. If we extend this tree, then we have S upside, S downside, upside, downside. And here, if the tree is symmetrical, upside, downside, downside, and we could go on. So in this case, we need to determine two numbers: the risk neutral probability, which is given by the downside and the upside movements, the time and the risk-free rate. There's an exponential there because we are discounting or capitalizing to present or future value. So in this case, the risk neutral probability, which is a number with similar to a probability, is not the real probability of the asset's price going up or down. It's just a number with properties which are similar to a probability. And if you like to read more about this, go please to chapter 8 in our book. So the risk neutral probability is 0.78 in this case. It will always be a number between 0 and 1. And then we have the option value. In this case, we are calling it F because it could be a call option or a put option. Sometimes you will just see the name C. This is the premium that we estimate for the option, how much the contract is worth. And as you can see, it's a weighted average with probabilities. The payoff, if it goes up, the payoff is if it goes down, and discounted to present value. If we go back to these numbers, we can see how much money do we make if the price of the underlying asset goes up. Then here, the value of the call, if the underlying asset goes up, will be the following. We are going to buy an asset which is worth 75, but we can buy it for 50, which is the strike. So CU is 25. But the price could go down, the price of the underlying asset. If it goes down, then how much is the payoff of the call? CD. It will be 0. We will not exercise this option because we will not pay 50, which is the exercise price, for something that we can buy in the market cheaper for 25. So it will be 25 or 0. These two numbers, as you can see, are here. 25 times the probability P, or 0 times 1 minus the probability, 1 minus P. Probability is this number we just calculated up there. And we discount for delta T, we discount back to the 3. So the value of this call is very simple, is 1526. Now let's work with a little bit a bigger tree, and we need to build a model in Excel. There are many ways you can do this. We can work in this way with a tree where first we calculate the tree for the underlying asset. We only need the last branch. So the tree for the underlying asset is there in one column. It could be there or in the right part of the worksheet, it doesn't matter. Then we have two formulas. This is an European option, so at the moment of expiration in time 6, we need to decide whether to exercise or not the option. If it's a call, when do we exercise? When the underlying asset is higher than the strike. In other words, this is the price we have the right to pay to buy the asset. So we will exercise this option in a call. We will exercise this option when we have the right to buy cheap, when we have the right to buy a strike which is small compared to the current price of the underlying asset. In a put, it's the reverse. It's exactly the opposite. We are bearish in this case. So the formula for the last column will be max between the comparison between the strike and the underlying asset, or 0. We will never exercise an option at a loss. We simply, if it's not convenient to exercise, we just simply leave the option to die worthless. So it's going to be the maximum between the exercise value or 0. Then there's another formula which we are going to use in all the other cells. That is the one I showed you a moment ago, kind of an expected value. For example, here, this is an expected value between this number and this other number, from the upside and the downside numbers, and discounted for one interval backwards. So we start here, and then we can copy the formula left and down for the tree. Let's work with a numerical example in Excel. This is a 4-steps tree that we are going to value using risk-neutral valuation. The price of the underlying asset today is S, but it could go up by an upside movement, or 2 upside movements, or 3 or 4. In other words, 1, 2, 3, or 4 times. So N is 4 for steps for the tree. The underlying asset price is 10 today. The upside movement is 125, and we define the downside movement by 1 divided by U, which makes the tree symmetrical. The option is in the money. Strike is only 8. And time to expiration, in this case, is 4 years, which makes delta T 1. 4 years divided by 4 steps. Then the risk-free rate is 5% per year. Now we need to calculate the risk-neutral probability, which depends on the downside movement, the upside movement, and a capitalization factor, which is exponential, and the risk-free rate times delta T minus D, the downside movement, which is 0.8, and divided by the upside minus the downside movement. In other words, 125 minus 0.8. So the risk-neutral probability is always a number between 0 and 1, is 0.55 in this case. Now, it is convenient to calculate the discount factor, which is the exponential of minus the risk-free rate times delta T, 0.95. And the value of the call will be the result of solving the binomial tree. So we need to work with all the tree from the right to the left, and then we can find the option value. This is a premium that we will pay for the option. Now let's see the tree of the underlying asset. The underlying asset today is 10, but it could go up to 1250. In other words, 10 multiplied by 1.25 is 1250. And it could go up again by 125, or it could go down by 0.8. So we need to solve the tree of the asset, we need to go up until the asset is multiplied by the upside movement 4 times. This is a 4-steps tree. Again, time to expiration is 4, the number of steps is 4, delta T is 1. Now we can write this tree in the light blue cells there in the right. We don't need the whole tree. We just need to calculate how much is the underlying asset going to be if it goes up 4 times or down 4 times. We need like the borders of the tree. We're going to write them in this column, and so the upside movement in the which you can see in the top right branch of the tree, it's going to be S, $10 times or multiply by 4 times the upside movement. So S today, the underlying asset today, multiplied by the upside movement, elevated to the power of 4, which is the number of steps. Okay, So from 10, which is today the underlying asset, it could go up to 24.41. That's the maximum. Then we can go down simply by multiplying by D, because this is a symmetrical tree. So we can simply go down, and as you can see in the middle, in 0, we have the price today. So we're doing this and this, like the borders of the tree. This is in the light blue cells. We don't need the cells in between. We don't need this part in between the tree. Okay, now we can, now that we have estimated 24.41, this is what we have in the light blue cells. And this is what we have in 0. And then if we go down by D, the price will go from 10 to 8, 640, 512, 410. So that's those are the borders of the tree that we have in the light blue cells. That's all we need. We don't need the others. So from 24.41, which is up there, and then down by D, multiplying by D, we calculate all the borders of the tree, and then obtain the last number, which is 410. And that is the price that the underlying asset will take if it goes down 4 times in a row. Okay, now let's solve the tree, but for the option, not the underlying asset. Now let's work with the option tree, which is in orange cells. Again, this is a call option. In period 4, what we need to do is to decide whether to exercise or not the option. So here we will write the max between the underlying asset price at that time. It depends on time. That is why it's called ST. It depends on time. Minus the strike. For example, if the underlying asset goes to 24.41, we have the right to buy the underlying asset at $8. So we're going to make a profit. The payoff of the call will be 16. We exercise, we pay 8 for something that is worth 24 in the market, so we gain 15. I'm sorry, 16. Okay, I'm going to copy the format here because some cells are not necessary. Now we go back in the tree, simply calculating the expected value. 16 times the probability plus the other branch of the tree, which is 7.63 times 1 minus the probability. So the payoff of the call up and down and times probability, or 1 minus probability. And we discount all these multiplying by the discount factor. We multiply by the discount factor. Okay, we can copy this formula. It's an expected value. We are working backwards. So that's why we discount. We can copy it up and down for all the tree. But as you can see, some cells are correct, others are not. If you can see there, I'm using a cell that is not correct. So we can adjust just moving inside the tree. There I'm using a blank, an empty cell. So I just adjust moving in the tree, and this is a trick for us to be able to copy the formula left for the whole tree. Now we have, I'm going to copy the format only to identify where the option value is. It's 382. That's the option value at the trunk of the tree. And we simply have used 2 formulas, one for year 4 and copy down, and another formula for all the other branches, which we have adjusted. Okay, 382 is the value of this call option. That's the premium that we should pay for the option. Thank you very much. You can see more details in our book. I'll see you soon.